This is the Precalculus Mid, second 9 weeks common assessment, and this will be a preview, and you can thereby, with this preview, understand all the types of problems that are going to be in our upcoming test. The first one we're going to look at here is the quotient of x to the fourth power minus x squared plus 3x minus 1 and x minus 2. So say quotient, what we're looking at is we put this x to the fourth power minus x squared plus 3x minus 1 as a dividend, and this x minus 2 is a divisor. And what we do is set up a proper synthetic division would be to take the coefficients of the dividend, and we have 1 x to the fourth, and you see that we don't have x to the third here, so we put 0 x to the third power, and then we have negative 1x squared, and then 3x, and then negative 1. And lastly, we have to put the 0 or the divisor here, so we take x minus 2 and set that equal to 0. Our related 0 is going to be x equals 2. So if we put 2 out here, this would be our proper synthetic division setup. And that would be our answer to this problem. Next, know graphically what inverses of functions are. So basically, if we have a function like f of x equals 2x, then our inverse of that would be, if we say y equals 2x, and we switch x's and y's, we have x equals 2y divided by 2. We get y equals x over 2. So therefore, our inverse function for the original is going to be f negative 1 of x is equal to 1/2 x. And so what that would look like is this. We would have a function f of x equals 2x. Looks like this with a slope of 2. So f of x equals 2x. And then we would have its inverse would be f negative 1 of x would be 1/2 x. And what we're looking for is these two functions who reflect about the line y equals x. And so when you have a different types of things that can be, I'm going to make different colors. If you have an exponential function e to the x, that's going to be the inverse of the logarithmic parent function ln x. If you have a cubic function y equals x cubed, that's going to be the inverse function to y equals cube root of x. Okay, and so anyway, just you know what those are. Next, what is the remainder of division x to the fourth power minus 3x cubed plus 4x minus 5 over x plus 2. There are two different ways you can do this that we've done in class. You can use one thing we call the remainder theorem. And for the remainder theorem, what we do is we take the 0. So if we take x plus 2 equals 0, x equals negative 2 is our 0. So if we take f of negative 2 and plug that into this x to the fourth, we put negative 2 to the fourth, minus 3 times negative 2 to the third plus 4 times negative 2 minus 5, we're going to get a remainder. And negative 2 to the fourth power is going to be 16. And then negative 2 cubed is going to be negative 8. And negative 8 times negative 3 is going to be plus 24. And then we have plus 4 times negative 2, that's going to be minus 8 and minus 5. So 16 plus 24 is going to be 40, minus 8 is 32. 32 minus 5 is 27. So our answer for remainder would be 27 over x plus 2. That would be a correct answer. And another thing you can do is use synthetic division. And to do that, it's just going to be as easy, pretty much. You put 1x to the fourth. We have negative 3x cubed, 0x squared, 4x, and negative 5. And outside we put the 0, negative 2. Bring down the 1. So negative 2 times 1 is negative 2. Negative 3 plus negative 2 is negative 5. Negative 2 times negative 5 is 10. 0 plus 10 is 10. Negative 2 times 4 is, negative 2 times 10 is negative 20. 4 times negative 4 plus negative 20 is negative, that's negative 16, yeah, negative 16. Negative 2 times negative 16 is 32, and negative 5 plus 32 is 27. So by this mechanism, we also get our remainder of 27 over our divisor x plus 2. Okay, so just make a choice. Either method would be great. Next, write a polynomial function that has an odd degree and is negative. Well, an odd degree would be like would be a leading term that would have like x cubed, x to the fifth, x to the seventh, and so on. And negative would be to have a negative coefficient out front. Any of these with a leading term, so we have, if we have f of x equals negative x cubed plus 3, this would be a polynomial function that would be an odd degree and negative. If you had one that would be f of x equals x to the fourth plus 5x plus 3, this would be even degree positive. I think on this one you're going to be asked to produce options from a multiple choice selection. But this would be an example of a correct answer to this problem. Next, according to the rational roots theorem, what are the possible rational zeros of the function f(x) equals x cubed plus x squared minus 17x plus 15? Basically, what we're looking for is our answer is going to be plus or minus factors of last term over factors of coefficient of first term. So what we're going to have for this is we're going to have plus or minus what are the factors of 15? There will be 1, 3, 5, 15 over the factors of the coefficient of the first term, which we have is 1. So this is pretty simple. So our answer is going to be plus or minus 1 over 1, plus or minus 3 over 1, plus or minus 5 over 1, and plus or minus 15 over 1. So that would be our solution set for this particular problem. Okay, next, what is the domain of the function fx equals x cubed over x times quantity x plus 4? You could play around with the calculator with this and see the exclusions, but basically, there are exclusions to the domain where the denominator is equal to 0. So if we set our our denominator not equal to 0, we would know through the zero factor property that x cannot equal 0, and also x plus 4 cannot equal 0. So therefore, x cannot equal 0, and x cannot equal -4. So they would be the exclusions to our domain. And so therefore, our domain, if we wrote this on the number line, would be at -4, and at -2, at 0 would be our critical numbers. And so we'd be looking at our domain would have a number line notation. But everything else would be defined between -4 and 0, greater than 0, and then less than -4. So in interval notation, we would have -infinity all the way up to and not including -4, union greater than -4 up to but not including 0, and then greater than 0 all the way up to but not equal to infinity, so less than infinity. So this would be our domain. And what our numerator happens to be doesn't have a bearing on what our domain of the function is. Okay, what are the real zeros of the function? In g of x, we have this. Well, what we can do is we can set this equal to 0. So 0 equals x times quantity x plus 2 times quantity x minus 3 times quantity 2x minus 3 times quantity x plus 5. So using the zero factor property, we can set each of these factors equal to 0. So the first factor is x. So x equals 0. We have x plus 2 is equal to 0. We have x minus 3 is equal to 0. We have 2x minus 3 is equal to 0. And finally, we have x plus 5 is equal to 0. And if we solve all these, we have x is equal to 0. That's one of our zeros. If we subtract 2 here, we're going to have x is equal to -2. That is a 0. If we add 3 to this one, we have x is equal to 3. And this one here, if we add 3, so we get 2x equals 3. And divide by 2, we get x is equal to 3 over 2. And finally, we from this last one, subtract 5, we have x is equal to -5. So these are our zeros. We have x equals 0, x equals -2, x equals 3, x equals 3 over 2, and finally x equals -5. Okay, let's go on to the next one. The cubic function fx equals x cubed minus x squared minus 8x plus 12 has two distinct real zeros. What is the value of the zero that has a multiplicity of 2? So let's go to our graphing calculator and enter it in here. Here's our TI-84 plus CE calculator, and we put x cubed minus x squared minus 8x plus 12, and go to zoom 6. Looks like we have a distinct zero at x equals -3 and at x equals 2, and we could check in our calculator. So x equals -3, x equals 2. Now, these are two distinct real zeros. So what would be our one with the multiplicity of 2? The one with the multiplicity of 2 is going to be this one right here, where x equals 2. That has a multiplicity of 2. So multiplicity equals 2. So therefore we would put into our formula, and the algorithm assumes positive. So you don't have to put plus 2. So that would answer question 3. And basically what you have, looking back at you have an even numbered multiplicity where the graph function touches but does not cross the x-axis. And you have an odd number multiplicity when the graph function actually does cross the x-axis at that x value. Next, if f of x equals x cubed, x squared plus 6, and g of x equals x minus 5, what is f of g of x? And that would be the same as f of g of x. Well, basically what you do is you take your x minus 5 and put it in the place of this x here. Let's go see what that is. We'll put f of g of x is going to be equal to, we're going to put in the place of x and x squared, x minus 5, and we square that, and we add 6. And when we multiply all this out, we're going to x squared minus 10x, and negative 5 squared is going to be plus 25. And we add this 6, and so our answer to this is going to be f of g of x is going to be x squared minus 10x plus 31. So that is f of g of x, which is the same as this Okay. Next, for the data at the table, which type of function would best model the data? You're going to get in your test a table that you're going to look at the values for and determine what type of function you'd be given, like linear, cubic, square root, quadratic, and I don't know if there are other choices, but what you'll do for this one, or the best one to solve this, you graph it by hand, but just go to your calculator, go to second quit, and you go to stat edit, and just enter the values. And here I'm going to do that. -1, 0, 1, 2, 3, 4. And then the output value is going to be 15, 10, 5, 3, 6, 16. So these are all the values here, and you could graph these. I'm going to clear this out, and we have plot 1 turned on. Graph, we can kind of see sort of what they look like, but even better, we can take this zoom 6, zoom 9 for zoom stat. So that's what it would look like. And this one looks like it could be like a cubic or quadratic. It's actually supposed to be a cubic. It doesn't quite fit a quadratic. But what you would do is you would graph, you would plot like this and look at it. What would be the best match for it? And you can try different equations, do the regression analysis on this. I would say for this one would be maybe a quadratic or perhaps a cubic function would be like a best fit for this, but you'd have to decide, and there'll be some good options for that. So I'll say maybe quadratic. On your test, it's going to be a lot more clear what your answer is if you do go that as far as I did. Next, radioactive substance C14 has a half-life of 5,730 years. Equation shown where 100 grams of C14 decayed into 15 grams. How long would it take 100 grams to become 15 grams? And basically, you can solve by graphing. See where, if you solve one side for 0, if you say 0 equals 100 times 0.5 to the power of x over 5730 and subtract from that 15, you can graph and see where the graph touches or crosses the x-axis, and that'll be your answer. Or you can solve this using the properties of relations of exponential and logarithmic functions. You divide by 100. So that'd be 0.15. So 1/2 to the power of t over 5730 equals 0.15. I want to put this 0.5 to the power of t over 5730 equals 0.15. So what you can do is take 0.5 to the power, actually make it log base 0.5 of 0.15 equals t over 5730. And you can find what t is by cross multiplying. I'm just going to write t is equal to 5730 times log base 0.5 of 0.15. And you can use change of base of logarithms. A lot of different ways you can do this. Let me go ahead and calculator show you what it is. So clear out here, 5730 times, and what I'm going to do is go to math, and I think we can go down to log base. There it is, log base 0.5 of 0.15. Or we could use a change of base formula on that. And so we're going to get in years 15,683 years. And so we can just put it in here like it's 15,683. So here's 15,683. I'm going to show you how you can graph and calculate it too. There we go. So I'm going to put this equation up here. I'm going to make that f of x. So here it is. Oops. We'll put in, let me get this here, 100, make sure I get this right, times 0.5, times 0.5 to the power of x over 5,730. I'm going to subtract 15 over here. And so we have this in the graph, and we don't see anything. We have to get the right. I am going to get rid of this plot thing. And the window, we're going to start at 100 grams. Oops, actually we're going to start at 0 years. That's the time, 0. Okay, we're going to go up to 30,000 years. Go by thousands. We are going to y minimum, we'll go to -10, y maximum 100 maybe. Then a y scale, go by 10 maybe. Okay, with graph, we're going to see where the thing crosses the x-axis. So the second, trace, 0. When we have left bound, go to the left, press enter. There's right bound, go to the right, press enter, enter once more. We get 15,683. So that's solving by graphing. Next, earthquakes intensity using the Richter scale is based on movement in micrometers, If A is the observed movement in micrometers, then a Richter scale can be found by using the formula R equals 3.75 times log A. What is the Richter scale measurement of a quake whose amplitude A measures 2200 UM to the nearest 10th? Well, our formula is going to be R is equal to 3.75 plus log of 2200. So we can just put this in our calculator. So we have right up here 3.75 times, or times, plus log of 2200, and we're going to get to the nearest, we get 7.09, the nearest 10th would be 7.1. 7.1. So 7.1 is going to be our answer. And we can enter it like this, 7.1. So pretty straightforward when you get that problem. Next, solve the following equation for x. We get 81 times 0.2 to the power of 16 over x equals 0.081. Now, the easiest way to do this would be just to solve this for 0 and graph. So if you subtract 0.81, you're going to get 0 equals 81. times 0.2 to the power of 16 over x minus 0.081. So for this, you would just change this 0 to f of x. So I'll go to calculator and we go 81 times 0.2 to the power of 16 over x, and from this we're going to subtract 0.081, and where the graph, oops, I guess subtract one. Okay, second insert, subtract. Okay, that should do it. And again, I'm going to go to standard window zoom, standard which is 6, and you can kind of see what it looks like here. We can zoom in a lot better if we go from 0 to, we'll just leave that as 10, and go from our y minimum of -1 or y maximum of 1. We should be able to see where the thing touches across the x-axis. It looks like it's going to be between 3 and 4. Again, we'll go second, trace, 0, and we have the left bound first. We'll go to the left of our x-intercept. Oops. I need to clear out second, trace, 0. Okay, go to the left, press once, then go to the right, press twice. We get about 3.728. And there's another way you can do it too, is you have this equation here. You can divide, I'll do it really fast, 81 plus 0.2 to 16 over x equals 0.081. So if you divide by 81, what you have is you have 8.1 times 10 to the -2 over 8.1 times 10 to the first power, and so you're going to get 10 to the -3 power, and that's going to be equal to 0.2 to the power of 16 over x. And then we can go ahead and take, we can switch around. We have the base of the exponent can be the base logarithm, so we have log base of 0.2 of 10 to the -3 power equals 16 over x. And then we can cross multiply the x and divide by log base 2 to 10 to the -3 power. So x is going to be equal to 16 over log base 0.2 of 10 to the -3 power. And you're going to get the same answer that way. So just we'll use the change base formula. So we'll go here. So we get this 16 over, we're going to have log of 10 to the -3. So we have log of 10 to the power of -3 over the log of 0.2 . So we'll get the same thing, 3.728. Okay, this is going to be our right answer. And plugging this in here, 3.728. And it doesn't say to what place, decimal place. If you're asked to bubble it in, it'll give you more exact instructions. 3.728. And here we have it. Okay, next. For the quartic function whose graph is shown, how many real and non-real zeros are there? Well, this gets down to the understanding of the fundamental theorem of algebra, and that is that the number of zeros, real and non-real, is equal to the degree of the polynomial function. And for a quartic function, we're talking about an x to the fourth degree, and we know this is going to be some kind of negative x to the fourth degree. And we see two real zeros, each with a multiplicity of 1. So real zeros, we know we have two real zeros. And we know through the fundamental theorem of algebra that just by we're going to have 4 minus 2 equals 2 non-real zeros. So the zeros, real and non-real, are equal to the degree of the polynomial function, and some of the zeros may be repeated. That would be our answer for this one. Next, formula for Newton's law of cooling is this one right here. A cake is removed from an oven at a temperature of 410 degrees. Room temperature equals 70 degrees. How long after being removed from the oven will the cake reach temperature of 95 degrees Fahrenheit if K equals 0.046? So what we're going to have is our formula is going to be T sub T, which is going to be our final temperature of 95 degrees. It's going to be equal to the temperature of the medium, which is 70. It's going to be plus, we have 410 minus our medium temperature, which is 70, e to the negative, and K is given as negative 0.046, and that's going to be T. So we can simplify here, subtract 70, and so we have 95 minus 70 is 25. And then on the right side, we have 410 minus 70 is going to be 340 e to the negative 0.046 t. If we divide by 340, we have, I'm going to work below here. We have e to the negative 0.046 t is equal to 25 over 340, and then just kind of working up here, drawing arrows. If we take the logarithm, natural logarithm of both sides, put ln, we have ln and e cancel each other. So what we're going to have is negative 0.046 t is equal to the natural logarithm of 25 over 340. And so if we divide by negative 0.046, we're going to have t is equal to natural logarithm of 25 over 340 over negative 0.046. And we'll put this in our calculator. Okay. Natural logarithm of 25 over 340, and we divide this by negative 0.046, we should get our y amount of time. So looks like it'll be to the 10th of a minute, 56.7 minutes. Rather than nearest minute. Okay, well that's going to be, so nearest minute is going to be 57 minutes. So we'll put 57 right here. And here it is. Okay. Next, using basic exponential equation, and we're given the equation here where t is number of years. What will be the population after 11 years? The initial population is 540,000. And population increase at rate of, so this one r is going to be equal to 0.034. And so 1 plus r, I'll just write out here, our population is going to be 540,000 times 1 plus 0.034 to the power of t, which is 11. We can just put that in our calculator, and I'm going to have 540,000 times 1.034 to the power of 11. And for that, we get 780,045. So 780,000. So that is it. 780,045. So that'll be it. Okay, next. The pH of the solution given by equation, pH equals negative log x, where x is the hydrogen ion concentration moles per liter. What is the pH of solution with hydrogen ion concentration of 10 to the negative 2.3 moles per liter. So the pH is going to be equal to negative log, that's going to be log base 10 of 10 to the power of negative 2.3. So we can put this in our calculator, and it's going to be pretty easy what it is. So let's put it in here. We have negative, make sure I get this right, negative log base 10 base 10 of 10 to the power of negative 2.3, and we should get a pH of 2.3. And there it is, 2.3. Highly acidic, by the way. Okay, next. Well, the formula for sound intensity is B equals 10 log I over I sub 0, where B is in decibels, I is sound intensity in watts per meter squared. I sub 0 is 10 to the negative 12 watts per meter squared. Sound intensity vacuum cleaner is 4 times 10 to the negative 3 watts per meter squared. Where's the sound measure in decibels? Well, we're going to put our sound measure in decibels is going to be 10 log I, and I is 4 times 10 to the negative 3 watts per meter. We're going to divide that by 10 to the negative 12 watts per meter. So really it's just a matter of putting this in the calculator. So we go here, we put 10 log, get a fraction here, and then where we put 4 times 10 to the power of, and make sure I get this right, 10 to the negative 3 power, over 10 to the negative 12th power, and right here, close parentheses, we should get, so we get 96 decibels. So decibels, and then we can put this in here like 96. So here's a 9 and a 6. So there we have it. Should be pretty easy with formula. Mark has an investment account worth $10,100. What would the account value be worth 8 years later if the value compounds continuously at an annual rate of 8.3%? And this is the one, the continuous, it's A, the amount equals the principal, times e to the power of RT. Well, R is going to be equal to 0.083. So our amount is equal to $10,100. And we have e to the power of 0.083, and we have 8 years. So that's going to be pretty easy in our calculator. Oops. I want that. I want my calculator. 10,100 times E. Okay, second. E to the power of, we had 0.83%, I think. Yeah, 0.83 times 8. 0.083 times 8. So that's going to give us $19,620, the nearest dollar. So $19,620, the nearest dollar. And that's it. Okay, if x equals, this right here, what is the value of 0? It has a multiplicity of 2. Well, it's going to be this one. We have x plus 2 equals 0. That has a multiplicity of 2. So subtract 2, we have x is equal to negative 2. So that's going to be the value of our 0 with multiplicity of 2. So in this case, we're going to put negative 2. We've got to make sure that we bubble in our negative sign for this one. And that's going to be our correct answer for this one. If g of x equals 1/2 x minus 3, and actually got this wrong. If g of x equals that, what is f of 5? So what we have to do is to find f, we have to take the inverse of this. So to do that, we take y equals 1/2 x minus 3. So we rewrite that as x equals 1/2 y minus 3. Solving for y, we add 3. So we have 1/2 half y is equal to x plus 3. And then if we multiply both sides of the equation by 2, we get y is equal to 2x plus 6, which is going to be, because that's going to be the inverse. So we call this f of x equals 2x plus 6. Now if we plug in 5, f of 5 is going to be equal to 2 times 5 plus 6 is going to be equal to 16. So our answer for this one is going to be 16. Okay. And okay, if Heber City has a population of 15,500 at the beginning of 1999, during what year will population reach 21,000 if the population growth rate is maintained at a 2.6% rate of growth? So for this, we would have 21,000, which our final population is going to equal 15,500 times, we have R is equal to 0.026. So our base is going to be equal to 1 plus 0.026, which equals 1.026. So we have 1.026 to the power of t, or x. I'll put t here. And so you can divide, you can solve by graphing. If you divide by 15,500, we have 1.026 to the power of t equals 21. And we can cross out these two last zeros. So I'll put 210 over 155. And then if we make a logarithmic function, we can take log base 1.026 of 210 over 155 is going to be equal to t. We can find that. And we can just do a change of base on that, or I'm just going to use the logarithmic thing in here. So we have math 1.026, and we're going to have, let's see what it is, 210 over 155. So 210 over 155, we should have it, so 11.83 years, so 1999 plus 11.83 is going to be 2010.83. So during 2010. So 2010 would go right here. So we put in 2010. So there it is. Okay. Okay, that's it. Well, this should be helpful to you. These are all the types of problems that are going to be on there. Good luck, and thanks for viewing.